So the first thing we're looking at today is postulate / axiom and theorem. A postulate or axiom is a rule that is accepted without proof. A postulate or axiom is a rule that is accepted without proof. A rule is accepted without proof. We don't need any evidence or be able shown that it is true or not. It is just understood to be true. We just take it as fact. Now, a theorem is a rule that can be proven. And we will go through and prove most of the theorems that we cover in here. Or at least I will prove them to you and show you how they work. And you'll see that they are true, that they do work. So that's the main difference between a postulate and axiom and a theorem. The theorem can be proven, and the postulate or axiom is just accepted as a truth or something as true. It's accepted without proof. Okay. Okay. You're good. Okay. Now, the first postulate that we have is the ruler postulate. You don't have to write this all down. Really, the ruler postulate says if we have 2 points on a line, if we subtract their locations and take the absolute value of it, we can find its distance. So on a line, if this was at 7 and this is at 9, well, 9 minus 7 is 2, so the distance from A to B is 2. Yes? Yes. So the distance between any 2 points, if I take their values assigned on a number line, I can subtract them, and that tells me the distance between them. Because if I were to measure it, I could put a ruler up next to it and say that this is 7, this is at 11.4, and we could subtract it and see how long or the distance between those 2 points is. That's all the ruler postulate says. Now, normally, if we were going to do this, we really wouldn't use the ruler postulate. Like if I want to find the length of ST to the nearest centimeter, but I put a ruler up there and I would zero it out. Because I'd put 1 point at 0 and then see where's the value of the other point. Now, this isn't going to be the same scale as what's on your paper. Because here is 0, this is at 3, 1, 2, 3, 4. Well, the distance from S to T would be what? 3.4. Because we know 0, 3.4 would be a length of 3.4. Now, by the ruler postulate, what we're saying is we're taking 3.4 and subtracting it from 0, the absolute value of it. Well, 3.4 minus 0 is 3.4, and the absolute value of it is 3.4. I mean, that's just how we use a ruler. Because I think everybody in here knows how to use a ruler. Yes? Okay. So I'm not going to worry too much about measuring lines. There's actually not going to be an assignment over how to measure a line. We're not dealing with that. Now, there is something else that we may or may not get to eventually, and that is constructing and comparing congruent segments. Now, it is possible to construct and create a line segment without a ruler. To make 2 identical lines that have the same length without a ruler. And what we use is what we call a compass. this here is able to copy any line segment. So if I wanted to, I could draw, well, apparently I can't. There's one. A straight line. So I could create a straight line, and with the compass, what I do is I open it up so that the two endpoints are at the two endpoints of the line. And then what I can do from there is take this and put it down here and mark. And what that tells me is that from here to here is the same length as our original line. I can create that distance. I think most of y'all have seen, hopefully have seen some type of naval movie, some type of movie that has a boat, and you've seen them use a compass-like device and walk it across a map. You know what they're doing? Measuring. Yeah, because any map has a scale of how many miles the scale is, and what they can do is they can take this and do essentially what I just did and see how the scale goes across. So they could walk it out by going here again, again, and again to see how far away they are from it according to the map. So it's a useful little device. We may or may not get those out, but that's kind of what it is and what it does. So we're not too concerned with those there. Now here's the first real thing we'll do, or first thing that will definitely be on the homework. Congruent segments. Now there is a lot here, but the main thing of congruent segments is that two line segments are congruent if they have the same length. If two lines have the same length, then they are congruent. If two lines have the same length, then they are congruent. Line segments that have the same length are called congruent segments. You can say the length of AB, line segment AB, is equal to the length of line segment CD, or you can say line segment AB is congruent to line segment CD. This equal sign with the wavy line above it is called congruent. And we'll use that to show or to say that two segments are congruent, are the same. Now, if you also notice here, we do have two statements. One of them is AB equals CD. It does not have the segment line above it. It does not have that segment line above either one of them here. And what this is talking about is not the lines themselves. It's talking about the length of the line. What this is saying is that the lengths, these two lengths, the measurement of their lengths are the same. So when it does not include the line, they're mainly talking about its length, the measurement of the line. Now when they do include our line segment symbol above the letters, we're talking about the lines themselves, that the lines themselves are congruent to each other. They are the same. And that's the big difference between these. We're talking about the lines. And there is a difference between them, because if we're talking about the lengths being the same, we don't have the bar above it. But if we're talking about the segments being congruent, we need the bar above it. Any questions on this so far? Let's look at our first example. And the miss. Plot points J, K, L, and M in a coordinate plane. Then determine whether JK, segment JK, and segment LM are congruent. And for them to be congruent, they have to have the same length. So let's plot point J first. So point J is -3, 4. The -3 is our x, and the 4 is the y value. So we'll go left 3 and up 4 to make a point J. Now the next point is point K. Point K has the x value of 2, +2, and the y value +4. So we go over to +2 on the x and up to +4 on the y and get point K. So we now have the line JK. Any questions on how we plotted those 2 points? I'm glad. So let's go on and plot point L. Point L is at 1, 3, so the x value is 1. The y value is 3. And we can plot point L. And lastly, we need to plot point M, which has an x value of 1 and a y value of -2. Any questions on how we plotted these 4 points? We're able to get the 4 points? Yes? Now, with what we're doing here today, we need to measure the distance. And well, since they're on a coordinate plane and they're along a straight line, we can just count the squares. Because each one of these squares is the same distance from each other. And this here is 1, 2, 3, 4, 5. So JK has a distance of 5 units. So what does LM need to be for these two to be congruent? 5. It needs to be the same. So let's see here. 1, 2, 3, 4, 5. So are they congruent? Yes. Since JK is equal to LM, they have the same distance, it means that JK is congruent to LM. So yes, they are congruent because they have the same distance. Any questions on this here? We good with this here? I will provide grid paper, graph paper for y'all for the homework. If you need more than one sheet, let me know. I do have more. Because again, doing these here is nice on a graph paper because it's going to be along straight lines. Because as long as it's along straight lines, we can just count the grid. Yes? Do what we just did? You're good? So this one here, we want to plot points A, B, C, and D in a coordinate plane. Then determine whether line A, B, and C, D are congruent. So point A is at -2, 4. I think it might be on the next page. And yes, it's hard to read the grid paper. The printers aren't great. B is at 3, 4. C is at 0 on the X, 2 on the Y, so we're going straight up. And 0, -2. Is everybody able to plot the 4 points? Yes. So if we count the distance, 1, 2, 3, 4, 5. Here we have 1, 2, 3, 4. So are these two congruent? No, because they do not have the same length. So what we could say is that segment AD, congruent CD. So how would I change it to be not? We can put a line through it. Just like with not equals, we can put a line through it. Same thing with congruent. These are not congruent. No. Or you can just put no.
So what you're saying is all them symbols that Sheldon makes on Big Bang Theory is all it is.
Huh? No, they're all true. All right.
That's cool. With her she's an actual.
Yeah, she actually has her PhD. Any questions on any of this here before we look at the next part? Okay.
Yeah, Sheldon.
Let's focus here. Yep, and now we are not. All right, guys. When 3 points are collinear, so if 3 points are on the same line, you can say 1 point is between the other two. Well, yes, because if 3 points are on a line, one of them has to be between the other two. Would you all agree with that? So, if I draw a line and I put 3 points on the line, one of the points has to be between the other two. It's just with any 3 points on a line, one of them has to be in the middle, no matter how we set it up. Now, when we say between 3 points on a line, one of them's between, this is what we mean. We cannot have a point off the line and it be between the other 2 points, because it needs to be on the line for it to be between them. This makes sense. You ready for the...
Yeah.
Yeah. Very good. Okay. You guys ready for this? I think I'm going to blow someone's mind.
That'd be me.
The segment addition postulate. If I know the distance between A and B and the distance between B and C, and I put them together, I get the whole length. That's the segment addition postulate. If we know one part and know the other, we can find the whole.
Why the heck did they have to give us a smart name for something stupid?
In mathematics, they wanted a way to prove and state that everything did hold true. That it wasn't something that worked most of the time. They wanted to definitely prove that it worked every single time. And that's what's going to be a lot of these here, is that these are proofs and postulates that seem like, okay, yeah, that's right, but especially back in ancient Greece, when, I mean, the technology and stuff they have wasn't as common. Stuff like this makes sense to us now.
3 snails wide by 4.
So let's look at this here. Not that one. Find DF. So if we wanted to find DF, according to the postulate, what it says is that DE plus EF is equal to DF, because length DE plus EF combine together to give us the whole segment. So DE is 23. And we can add those together to get the whole length. Because we can add the two together to get the whole. Questions on this here? We good with this one?
Yeah.
So if we wanted to find GH, well, according to the postulate, FG plus GH is equal to FH. Well, we know that FG is 21. GH we don't know, so let's call it X. And FH is 36. Subtract 21 from both sides. X is 15. So GH,
Why do you have to subtract them for both sides?
because we need to keep the equation equal. Balanced.
Why do you have to subtract it?
We did. So, XZ. How do we find the length of XZ? Is we can add those two together to get the whole.
73.
I alternate between using it and not.
Same reason why I wonder why people put slashes through their F's.
What?
Mm,
You're supposed to.
yep.
You're supposed to.
It's not F's, it's another seven. Yeah.
Personal preference. All right, guys. This one's not in your notes. You don't have to write it down. You don't have to write it down, but let's talk through this one. In the diagram, WY is 30. Its length is 30. Can you use the segment addition postulate to find the distance between points W and Z?
I didn't know if it would be that easy. Would it be 30 and 50, like she said?
Let's look back at the formula, or this here, the segment addition postulate. If B is between A and C, then this holds true. If B is between the 2 points, then it is true. So if it's between the points, they have to be on the same line. So can we find it?
No.
No, because it's not on the same. Yeah, it's not on the same line. We can't do it. Let's do this last one here, because I think y'all got the hang of this, yes? So what would we do? Which would be? So KL would be 107. Any questions on this here?
Are you in math and math?
No.
What is your like highest like?
Degree.
Yeah, what's your